All right, so let's take a look at this problem. We've got a polynomial function of degree 4. We want to find the zeros. We don't have really any kind of X method or technique or anything like that to help us other than a theorem that they refer to as the rational zero theorem, and sometimes it's called the rational root theorem. And it's limited in its power. It only helps us with rational zeros, not irrational, and it's not an existence theorem. There's no guarantee that it will generate an answer for us. All right, so let's look at the factors of the constant term. And that's 1, 2, 3, and 6, and well, plus or minus each of those. And these are going to be numbers that we put in a numerator. We look at the leading coefficient, and it has factors of 1 and 3, and that's going to be numbers that are in our denominator. So this list that I was talking about of possible rational zeros, there's no guarantee that any of these numbers will actually make this function equal 0. But if there is a rational zero, it'll be in this list. So we take each of these numbers and divide it by 1, and that just gives us this list back again. And now if we divide each number by 3, the 3 divided by 3 is 1, and we've already got that. And 6 divided by 3 is 2, and we've already got that. So here's the list that we need to check. All right, so we didn't have any greatest common factor. We don't have any missing powers on our exponent. We don't have any, so let's jump in and try 1, see if it works. Now, you don't have to do these in the order that I'm doing. I always try 1. I just start at the beginning and go all the way through. If you want to jump around, I just caution that you keep track of the numbers that you've tried. And this is not going to give us a 0, so I guess I could have stopped before then. All right, so let's try -1. So this definitely gives us a 0. All right. All right. So even though we've tried -1, it's possible that -1 could have a multiplicity greater than 1. So I generally test it again just to make sure. And hey, looky there, it does have a multiplicity greater than 1. So this polynomial function, we can begin to write it in factored form. This 3x squared minus 7x minus 6, if we do our x method. And since the leading coefficient is bigger than 1, I suggest you continue in a table. Along one diagonal, you put the first term and the last term. And along the other diagonal, put the values that you found from your x and factor both horizontally and vertically. So this factors to x minus 3 times 3x plus 2. So that's going to give us zeros. Of -1, +3, and -2/3. And even though the degree was 4, because that multiplicity was 2, look at the multiplicities, 2 plus 1 plus 1. Hey, we know we've found all 4 of them. There's no more. All right, well, I hope that helps, and I'll talk to you later. Bye.